time we talked about direct substitution. It's a super easy and amazing way to solve a bunch of limits. We just plug in the number. Yes. Now, there are times where we are going to get this nasty 0 over 0. That does not mean our answer equals 0. That does not mean it equals infinity. It doesn't mean it does not exist. We don't know. This is what we call an indeterminate form. We don't know yet. We are going to have to do some more manipulation to figure out what the limit is. But luckily, we do have techniques for it. The two big techniques, the common strategies we do to get past this nasty 0 over 0 is factoring and multiplying by the conjugate. So let's go ahead and look at one where we factor. So let's pretend that we go ahead and we just try and use direct substitution. We plug in this value as x approaches 3 onto this function. So we're going to get 3 squared minus 6 times 3 plus 9 all over 3 minus 3. Well, 3 minus 3 is clearly 0, so we know the bottom equals 0. Now for the top. 6 times 3 is 18. 3 squared is 9, so we have 9 minus 18, which is negative 9. And negative 9 plus 9 is 0 as well. So we get this 0 over 0. So what does this mean? We don't know. We don't know if the limit exists. We have to do some further analysis on this. And what we can do is factor the top. If you look and see that there's this quadratic up here, we need to find a number that adds to negative 6 but multiplies to 9. And those two numbers would be negative 3 and negative 3. So x squared minus 6x plus 9 is equal to x minus 3, x minus 3. That's how we factor the quadratic. But remember, there's an x minus 3 on the top and the bottom. But hey, we have an x minus 3 on the top and the bottom. So what this means is we can cancel out one of them. So what we're left with is x minus 3 on the top. And now we can take the limits. Right? The limit as x goes to 3 of this one, which is our original one, is the exact same thing as if we take the limit as x goes to 3 of this one. And this one is a super nice function that we can use direct substitution on. This will give us 3 minus 3, which equals 0. And actually, our answer is 0. So 0 over 0 might be indeterminate, but by factoring, we can figure out that the limit actually equals 0. All right. Let's go ahead. That's our answer. Let's go ahead and do one multiplying by the conjugate. So if we go ahead and use direct substitution right now, what we get is square root of 4 plus 5 minus 3 all over 4 minus 4. Well, 4 minus 4 is clearly 0. The square root of 4 plus 5 minus 3, well, square root of 4 plus 5, that's 4 plus 5 is 9. Square root of 9 is 3. So then what we get is 3 minus 3. That also equals 0. We have an indeterminate form. We're going to have to do some different stuff to try and get around this 0 over 0. And today what we're doing is multiplying by the conjugate. It is a very common technique. This was what we had before. To multiply by the conjugate, where we see the square root is usually where we multiply by the conjugate. And what we're going to do is the conjugate is the exact same thing as before. But since this is negative, we make the other one positive. And we multiply the top and the bottom, these two things together. We multiply these together and we multiply these together. So I'll put that dot right there. This right here is the conjugate. It's the same square root, but instead of there being a subtraction sign, what we actually have is a positive sign, an adding sign. So let's go ahead and FOIL this out. That's how we multiply these things together, right? So we have first, outer, inner, and last. X plus 5, square root of x plus 5, square root of x plus 5 is going to give us x plus 5. That's first. Now we have to do outer, the two outer terms, right? That's going to give us plus 3 square root of x plus 5. So we have 3 square root of x's plus 5s. Then the inner, which is I, the inner terms, which is negative 3 square root of x plus 5. And then L stands for last. Negative 3 times 3, which is equal to 9. Negative 9. So, on the bottom, what we have is the simplest way to do it, actually, and you'll get used to it as you see more of these problems, is we can just say that x minus 4 was getting multiplied to this thing right here. We don't actually have to do any foiling on the bottom. And the reason is it helps us cancel things out later. So what can we cancel out right now, though? On the top, we have a plus 3 square root of x plus 5, minus 3 square root of x plus 5. So those are going to cancel out because that'll give us 0. And then we have this negative 9 and this positive 5. 5 minus 9 is negative 4. So what we're going to be left with on the top is going to be this x minus 4. But hey, we have an x minus 4 on the top and the bottom. We can cancel those out. So what we're left with is this kind of implied 1 on the top. And then square root of x plus 5 plus 3 on the bottom. And this right here, after multiplying by the conjugate, this is actually a nicer function to do the limit on, and it will give us the same answer. So, if we use direct substitution now, what we get is 1 over 4 plus 5 plus 3. Square root of 4 plus 5 is the square root of 9 plus 3. That's 1 over 3 plus 3. Our answer is 1 over 6. So instead of us having a 0 over 0, that's just a cloak that's hiding what the actual solution is. We have to do something like multiplying by the conjugate to figure out what the actual solution is. All right, here's a quick check for you guys. Go ahead and try and solve these on your own and come back to see what the solution is. All right, welcome back. So on the top, the factoring is actually a difference of squares. So when you have an a squared minus b squared, what you can do is make it a plus b, a minus b. That's what we did with that x squared minus 4. And on the bottom, we did a multiplication by the conjugate. You can check the foiling for yourself. What you're going to get is this thing right here, which then you can use direct substitution, plugging in 0 into the square root of x plus 1. That's going to give you square root of 1, which is just 1. So 1 plus 1 on the bottom is 2. Our final answer is 1/2. And that is 2 techniques to continue using direct substitution and getting around 0 over 0.